Our goal for today is to talk about graphing radical equations, and specifically we're going to focus on square root equations, how do you graph them, and how do you graph cube root equations. And then we're going to talk about, after we've graphed the equation, we're going to look at the graph and we're going to identify the domain and the range, and we're also going to predict shift. So when you look at the equation and you compare it to the parent function, what does the shift happen? Are we shifting it left, right? Are we shifting up and down? And in the past, you guys have done a great job with that. So let's start with square root. Here is the parent function for square root. This is in radical form, which we learned about on the first day back from break. This is in rational form, and it doesn't matter which one you prefer to use. They're equivalent. Some students, when they see f of x in function form, they get a little confused. So if you even prefer to have a y equals, these are all equivalent forms. Okay, so we're going to get started. I want you to turn to your partner. Can you do me a favor? Jasmine, Jamie, can the three of you talk when it comes time? Okay, include Valeria as well. Thank you. Turn to your partner. What is the smallest number you can plug into a square root function and still get an answer out without your calculator saying error? Turn to your partner, 5 seconds, go. And you can use the calculator and try. Grab a calculator, try something. I heard somebody say 1. Do we know what the square root of 1 is? What is the square root of 1? Okay, that works. Let me grab a calculator that turns on. Give me 1 second. Okay, so we can check. Square root of 1, hey, that works. In the past, I've heard students say, well, there's not a square root of 2, or there's not a square root of 3. There is a square root of 4, because the square root of 4 is 2. There does exist a square root of 2 and a square root of 3. They're just not pretty numbers. They're irrational numbers, but I don't want you to think they don't exist. We just don't memorize them because they're irrational, okay? 1 is actually not the smallest number we can plug in and still get an answer that's real. Let's try 0. Square root of 0 is 0. So we can plug in, this is pretty important. We can plug in here, the input it's called. We can plug in 0 and any number above it. So we are allowed to plug in 0 and any number above it. When you were in 8th and 9th grade and you started to describe domain, maybe even without realizing it, you use this notation. At the junior level, we're going to use the notation that we've been using all year, interval notation. This is your input, also known as the domain. So without translating it, or without shifting it at all, this is what we have. These are the basic parent functions, the parent function for square root, and we know that the smallest number we can plug in is 0. So let's make a small table here. And to make our lives easier, let's only use the input or the x values of numbers you can plug in and get answers you already know exist. So I've heard you say that when you plug in 0, you get an answer of 0. When you plug in 1, I already heard the answer is. Remember, 2 and 3 exist, but they're not pretty, they're decimals. So what's the next one I can plug in and you already know the answer of? 4 goes with 2. Let's go a little faster. What's the next one? 9 with 3. And it doesn't stop, it keeps going, but realize that our graphs are not going to be this large, so this works out just fine. So I'm going to grab a piece of graph paper here, and I'm going to graph this. So I'm going to make dots at 0, 0, 1, 1, 4, 2, 9, 3. Recognize that these each represent an ordered pair on the graph of the parent function of a square root. So you can do this. You don't have to draw. You can draw an XY axis, but don't worry about making a grid. Here's 0, 0, 1, 1, 4, 2, and 9, 3. Good morning. Jamie, can you please tell your partner what she needs to grab up here? thumbs up or a thumbs down or to the side if you understood how we were able to come up with that graph of the parent function. Hands up high so I can see, please. Okay, most of us are up to the side, some of them at the medium level. Okay, now let's go ahead and let's talk about if we took that and we translate it. Let's make some predictions. So these are predictions. Don't write these down, let's just talk. Turn to your partner and based on what you've learned up to this year, what do you think we would do with this parent function that I have graphed in blue right now? What would we do if we added a subtract 3 inside the radical or a plus 2? 10 seconds to talk to your partner, you don't have to write anything down. Okay, inside the radical represents a horizontal shift. These are horizontal shifts. And just like you previously learned last semester, when you see a subtract 3, instead of actually moving like you'd think to the left 3, we move to the, this is going to be to the right 3. And this is going to be to the left 2 units. So I'm going to graph this first one in purple, and then we'll do the second one in blue. So I'm going to do this one again. I'm going to take all of the x values and simply shift them right 3. And you guys are good with memorizing patterns, and I think you've already memorized this pattern. So here's what I'm going to do. You're not every single time going to take time to graph the parent function, and then from the parent function move each one of these ordered pairs to the right 3. That would take a long time. So what I would tell you to do is start by going to the origin and shifting to the right 3. So I go to the origin, I shift right 3, 1, 2, 3, and I make a dot. This is now considered your new 0, 0. So look at that pattern that we created. This is your new 0, 0. What is the next ordered pair after 0, 0? It is, a little bit louder. So I pretend this is 0, 0. So to get to 1, 1, I go over 1, up 1. What's the next ordered pair after 1, 1? It is, so from this new origin, I go over 4, 1, 2, 3, 4, and up 2. And the final one I'm going to have to go off the graph will be 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm estimating. And up 3. And good to go. With your partner, can you please graph this one and talk your way through it? You have 30 seconds and then I'll go over it. Ten seconds remaining. Okay, and all eyes back up here. Thank you, Sebastian, for helping out there. Okay, so I am now going to shift it to the left 2. Shift it to the left 2. 1, 2, and put a dot here. This is now my new origin. You have to remember the patterns for square root. 0, 0, 1, 1, 4, 2, 9, 3. So 0, 0, 1, 1, 1, 2, 3, 4, 4, 2. And back here, I'm going 9. So here's 4, 5, 6, 7, 8, 9, and up 3. Can you please raise your hand if you and your partner were able to graph this same function? Hands up high so I can see. About half of us. Does anybody have questions about this? We're going to go back and talk about the domain here. And you're welcome just to watch if you don't want to write this down. The domain. So where is the first x that we can see a dot? Where's the first x? Do you agree it occurs on this x value? What is this x value? 0, and it's included because it has a dot there. So in interval notation, it starts at 0, and there's no restriction how far it's going to go to the right. So it goes to positive infinity. The second example, it starts at an x value of 3, and we include the 3 because there's a dot at that point. We include it with a bracket, and there's no restriction how far it moves to the right. Whether you write it down or just verbalize it, please do the third one with your partner. Go. Oscar, grab this, sit next to Sebastian. Yeah. Okay, starts at -2. No restriction how far it goes to the right. We include -2, and again, brackets on the symbol here, infinity, positive infinity, because we can't actually touch positive infinity. All right, so we've talked about horizontal shifts. Let's now talk about a vertical shift. We're going to include horizontal and vertical together, just to challenge you. Okay, turn to your partner and making a prediction. What do you think would happen in the first graph and the second graph? Just making a verbal prediction. You have 15 seconds. Go. Eddie, can you use your loud voice so that we can hear? I didn't hear you. It's okay if you're wrong. Can you make a prediction for the first one? What do you think happens? Please no talking, but except Eddie. Yep, left 4, down 1, and you just found your new vertex. We call it a vertex really because it's like a starting point. Remember, a vertex occurs with parabolas, right, guys? So I'm using the word vertex because it's like that starting point, but really it's your starting point of your graph. Okay, and let's go on to this one. Sarah Luce, what do you think we have here? Right 3 and up 2. So let me do the first one. You're only going to watch, and I'll have you do the next one with your partner when I'm done. So I'm going to go to the left 4 and down 1. Left 4, down 1. And I consider this like my new origin. New origin is really the word I want you to think of. Okay, and what is the pattern? Turn to your partner. I'll say the first. You're going to say the next 3. 0, 0. Turn to your partner. What is it? 1, 1. 4, 2. 9, 3. So here's 0, 0, 1, 1, 2, 3, 4, 4, 2, and 9, 3. Okay, let's talk about domain again because we're going to go back and do range after this. We're first just going to get a little practice with domain. We'll go back and do range of all of these afterwards. To your partner, please verbalize. What is the domain of this function? 5 seconds, begin. What x value does it actually start with? What x value does it start with? It starts on an x value of -4 and we include it. So it starts at -4 and we include it, and there's no limit how far it goes to the right. Okay, I'm going to flip over here. I would like you to graph this next function with your partner. When you're done graphing it, I want you to verbalize or write down what is the domain. I'm going to give you 25 seconds to begin. All right, I'm going to shift to the right 3 and up 2. From the original origin, I go right 3, up 2, and this is now my translated origin. For square roots, I use the order paired 0, 0, 1, 1. For 2, I'm going to have to estimate going off the graph here. 5, 6, 7, 8, 9, 9, 3. Okay, what is the domain? Kevin, can you please say what the domain is? Okay, I agree with the number 3. What goes on the outside of 3? A parentheses or a bracket? And why did you include a bracket? Because it is touching at 3, I agree. Okay, and what does it go to? Right, there's no limit. It goes to positive infinity. Nice job. Okay, turn to your partner. We have talked about horizontal shifts and vertical shifts, things you learned about last semester. But there's one thing we have not talked about. It's 2 words we use to describe it. What is that one thing? And where does it occur when you look at the function? 5 seconds go. Raise your hand if you have a guess. Okay, what if we put a number here? There's a hidden 1 here. What if we put a number here? And what if that number was greater than 1? What word would we use to describe it? We use the word stretch if it is greater than 1. And we use, if the number is between 0 and 1, we use the word compress. If the number in front of the radical is greater than 1, we use the word stretch. And if it's between 0 and 1, we use the word compress. What does that look like? Well, let me just draw a quick picture. This is a parent function of a square root. If I tell you we're going to stretch it, that means we're going to increase it. It's going to go up faster over time. So a stretch function is going to look something like this, an example. A compressed function, like if you compress the trash because you don't want to take it out, you push it down, it makes it flatter. Okay, so we're going to go back here. I'm going to go back to this original. We're going to go through talking about the range, and then we're going to add into these what does it look like when we compress or we stretch a function. Let's go back to this one. Going quickly through this and identifying the range. So in terms of y values, your first or your lowest dot occurs at a y value of 0. Is it touching a y value of 0? Yes. So the range touches a y value of 0, and there's really no limit how high it's going to go. It appears like it's going off to the right, but realize it's going off at a diagonal. And the way a diagonal occurs is it's being stretched to the right at the same time it's being pulled up. That's how this continues to go off at a diagonal. So there's no limit how high it will go over time. The range is from 0 to positive infinity for the parent function. If you feel like you understand this, you don't have to write it down, but realize you will have to do this for every problem today. Okay, so this is a translated function. We've already identified what the range is, or sorry, what the domain is. The range, what is the smallest y value we start with? This has a y value of 0, and it's touching at y equals 0. Again, no limit how high it goes, because as this goes to the right at a diagonal, it's being stretched to the right at the same time it's being stretched up. The range starts at a y value of 0, again, and it's headed up with no limit. All right, so this one has been translated, it's been shifted up and down along with a horizontal shift. Turn to your partner, verbalize, what do you think the range is? Go. Okay, the lowest we find this dot occurs at a y value of -1, and it is a dot there, so we're going to include it. Again, no limit how high it's going. Let me flip to the next problem. All right, and for this problem, we have the lowest dot occurs at a y value of 2. We include it because there's a dot at that 2. No limit how high it goes. Can you do me a favor right now? Up to this point, 1 through 5, how well you understand this lesson. Just tells me whether I can keep the same pace or slow it down. Okay, we're going to go on now to the scale factor in front. What happens? So, let me get a new piece of paper. Please write down this one. Our very first step is going to be to identify that new origin. In the past, students have asked, do I first shift it left or right and then up or down? It doesn't matter. So whether you do the horizontal shift first and vertical second, or vertical and then horizontal, it makes no difference. I personally take care of this first. So I'm going to shift it to the right 1 and then down 3. Okay, let's do that. We're going to go right 1, down 3. That's your first step. I now consider this the new origin. If you did not see a number out front, remember it's a hidden 1. When there's a 1, we don't use the word stretch or compress, okay? But we have a 2 here. So I can predict that this graph is going to move up at a faster pace over time, a faster rate over time. Okay, do me a favor. This is going to relate back to what we did last semester. We're going to do a simple 0, 0, 1, 1, 4, 2, 9, 3. Eyes open, Jose. Thank you. This scale of factor affects the y values. That's what allows it to go up faster or to become flatter. It affects the y values. So to each one of these, we're going to multiply by 2. 0 times 2 remains 0. 1 times 2 is 2. 2 times 2 is 4. 2 times 3 is 6. I'm going to cover this up. You will repeat these to me. So now I'm starting at our new origin, but instead of saying 1, 1, you'll say 1, 2. Okay, here we go. So here's my 0, 0, but instead of 1, 1, it is 1, 2. Can you please tell me the next one? What is it? 2, 4? My fault. 4, 4. Thank you. 4, 4 is the next one. So over 4, 1, 2, 3, 4, and up 4. And the last one is 9, 6. 1, 2, 3, 4, 5, 6, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure you do not, I want to make sure I wrote this. There's 1, 2, 1, 2, 3, 4. Oh, thank you. 1, 2, 3, 4, 5, 6. Thank you, Daniel. Okay, there we go. Okay, practice checkpoint quiz. Are you ready? You're going to have 20 seconds to do this. D and R. No penalty for wrong answers, but you must try. Please identify on your paper, not verbalizing, on your own and on your paper. Identify in interval notation. That's what we've been doing all year. What is the domain of this function? What is the range? Go. Jamie, can you share with me what you think the domain is? -1 to infinity. Can you tell me why you chose -1 and why you chose infinity?
Infinity because it has an arrow.
Perfect. I like that explanation. It has an arrow, so there's no limit how far it goes to the right. Good. Why did you choose -1?
-1 because
Okay, so you're describing it right, Jamie. You said that's where the x is, but actually what is the x value where this point starts? It's not -1, but Positive 1, correct? Yep. But you explained it correctly. Sebastian, can you please tell me what you think the range is?
-3
Yep.
and 50.
Okay, now we're going to go back right now and we're going to see, do you always have to graph it in order to identify the domain and range? Okay, you ready? Give me a second here. I think I unintentionally threw this out. Look at this problem right here. Can everybody see it? This is can everybody look please? This is the function, this is the domain, this is the range. Do you see any number in back that represents a vertical shift? If you don't see a vertical shift, that means there's no shift. What number would say no shift? Would it be 0? A lot of people want to say 1, but really what number is it? It is, look at this, there's 0. That's your y value for vertical. Here is your horizontal shift. Going on to the next one. This is your domain. This is your range. Again, there's no vertical shift. Starts with a 0. Here's your horizontal shift. Remember, it's the opposite number. Then we introduced vertical shifts. So in this problem, your domain starts at -4. Your range starts at -1. In this one, without me even flipping over, where does your domain start? 3. Where does your range start? 2. So here, where does your domain start? +1. Where does your range start? -3. Okay. Next problem you're going to do with your partner. I'll write it down. You'll have 30 seconds to do 3 things. I need you to graph it. Feel free to refer back to the notes. You're working with your elbow partner. And identify the domain and range. Your 30 seconds starts now. I'll walk around and you need to make sure you're working with your partner. Begin.
It's not 3. Oh yeah, it's 3.
Jesus, are you ready? Tell me your first step, Jesus. Just tell me, what would you do when you're going to graph it? Do you want a helpful hint? Yeah, so tell me where my new origin is and how did you get it? Do you agree with that, Fernando? I do as well. Okay, so myself, I go, okay, I've already taken care of this, I've taken care of this. Fernando, what do you do next in order to graph this? Because notice that we're going to have a stretch here. Okay, but before we multiply, I want to write it down. Can you tell me the original patterns that we have to have memorized for square roots? 0, 0, 1, 1, 4, 2. Thank you. Okay, now tell me what to do, Fernando.
Then you multiply it by 3.
And do I multiply the x's or the y's? The x's. Do you agree with that? Let's call on Oscar. Do you agree that we take this value of 3 and we multiply by the x's?
Yeah.
Yes. Okay, and why do you think, how many of you agree with him? We got 3 or 4? Well, think of this really quick. When we stretch something or we compress it, is it the y value that changes or is it the x value that changes? The y value. So that's why we're going to take, and that's okay. That led to a good conversation. That's why we're going to take each one of these, the y value is always times this. 0 times 3 is 0. 1 times 3 is 3. 3 times 2 is 6. 3 times 3 is 9. Okay, here we go. So I already have my new origin, 0, 0. Now I'm going to go over 1 and up 3. And over 4 and up 6. And over 9 and up 9. Destiny, can you tell me what you believe the domain is for this function? You're right. And what type of symbols do I use on the 3? Nice. Why? Yeah, it's included. It's touching. And what about on the infinity? You're right. Okay. Let's go on to the next one. Clarelli, can you tell me the range for this function?
Bracket and 5.
I agree. And let me just check. 1, 2, 3, 4, 5. That's correct. Okay.
Positive infinity.
Yep. And why is that? Why did you choose positive infinity?
Because it's going up forever.
Right. Going up forever. There's no limit. Nice job, guys. Okay. Let's see if I have 2 more. I'm going to see if I can stump you. Let's change this from going to stretch, which we can see rises at a faster rate. Let's do compress. Before you get started, notice that the -4 is not underneath the radical. Okay? Let's go 30 seconds with your partner, and then I will either go over this or I'll call on students. Begin.
-4 is not even
Valeria, can you tell me what's the first step you did in graphing this function? Okay, where is your new origin? You believe it's 0, 0? Can you tell me how you got 0, 0? Okay, you don't see any number here, so you associate with 0, right? I agree with your x. What is your y value that you see in this problem? So instead, our new origin should be at 0, -4. Good. Cassandra, can you tell me what's going to happen next? Use your loud voice, please. Yeah, multiply 1/2 here. 0 times 1/2 is 0. 1 times 1/2 is 1/2. 2 times 1/2, well, half of 2 is 1. And half of 3, well, if you had $3 and you had to split it among 2 people, you'd end up with 1.5. I hope I get that $2, Hector. You can keep the 1. Okay, so I have 0, 0. Here's my new origin. Then I go over 1 and up 1/2. And it's going to be over 1, up 1/2. You're going to be estimating here. Over 4, up 1. And over 9 and up 1/2. 1.5, up 1.5. So we can see that this is definitely a lot flatter. We're going to use the word compressed, okay? 1 to 5, how well are you understanding so far? Hands up so I can see, please. We have one more concept for today with this. We'll add in another kink to this lesson later, but this is the one thing. You're going to turn to your partner after writing this down, and you're going to make a prediction. And by the way, there's 4 predictions you're going to say with this. That is the last problem we will do. You're going to start right now. When I say go, you have 10 seconds to make what are the 4 predictions that you think are happening. You don't have to write down your predictions. Ready? You need to hear every group talking. Get set and go. Okay, I'm hearing great conversations. If you can stop, wrap it up in 3. Thank you, 2. Thank you, and 1. So hopefully by now you realize this is a horizontal shift to the right 5. This is a vertical shift up 6, right? Here's the misconception that, or excuse me, here's a common mistake I've seen, and I saw it all last semester. Students would write on previous tests, there is a vertical stretch of -2, and that's wrong. Because these are 2 different facts. Yes, because 2 is greater than 1, we say it's a vertical stretch of 2, but what does that negative sign represent, Hector?
It goes below the x-axis.
Yeah, right, it's going to reflect across the x-axis. So, the order you write your facts in doesn't matter. Horizontally shift to the right 5, vertically shift up 6, vertically stretch by a factor of 2, and reflect, or you could say flip, across the x-axis. Let's do a quick sketch. Let's go right 5, up 6. This is my new origin. I'm going to make a quick table, 0, 0, 1, 1, 4, 2, 9, 3. And I'm going to take this -2 times everything in the y column. So 0 times -2 is 0. 1 times -2, 2 times -2, and 3 times -2. When I graph, here's my new origin. Now I'm going to go over 1 and down 2. Over 1, down 2. Over 4, down 4. 1, 2, 3, 4. And over 9 and down 6. 5, 6, 7, 8, 9. 5, 6, 7. So now it's reflected across the x-axis. Okay, think to yourself, what is the domain, what is the range? And I'm going to call in 2 students. What is the domain, what is the range? Daniel, what do you believe the domain is?
Bracket 5.
Okay, hold on. Bracket 5, and I got to see it. Yes, x value starts at 5. Thank you. To infinity. Good. There's no limit how far it goes to the right. Nice job. I think range is actually tougher here. Kevin, what do you think the range is? I like it. Bracket 6, because we include the 6. Nice job. Negative infinity. Because remember, as this goes to the right, it is also going down. That's why it's going at a diagonal. Nice job.